Many of you, I'm sure, know Steve High. He's the president of High Environmental Health and Safety Consulting. We've partnered with Steve on seminars like this in the past. We also use Steve sometimes when we have clients who need help with an issue we feel like it's worthy of some deeper expertise. We get Steve involved. He does a great job, and I think you're all going to learn something from him this morning.
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 Happy St. Patrick's Day. I'm almost the only one who wore green. So hopefully with a little luck we'll get through this, and hopefully by going through this you won't be spending the green to OSHA, right? So my connection to St. Patrick's Day, it's the best I can come up with. So we're going to give you a little summary of kind of where I'm going to go with this session and what we're going to talk about. And so this is kind of the game plan. First off, this is called the top 10 hits, right? So we're going to be talking about the top 10 things that OSHA tends to cite, and particularly manufacturing and then also warehousing operations is kind of what I took a look at. So I'm going to talk to you a little bit about how I came up with this list. Okay. Secondly, I'll talk a little bit about OSHA's approach. How do they come to do inspections at facilities? How do they make determinations about what should be inspected, what shouldn't be inspected? We'll then walk through the violations, the top 10 list, and I'll talk to you about the requirements for each of the violations and then give you some tips to comply and some things where I see companies really struggling trying to comply, as well as, you know, what are some of the challenges with the regulations. I thought about printing out copies, and then I calculated it was 836 pieces of paper, so I decided not to kill the trees. So I made a PDF, which will be available to you as an email after the presentation. Okay? By all means, if you have questions as we go through this, please ask them. It's always much more interesting if you're interactive, and both for you and for me. Okay? So one of the things as we get into talking about OSHA regulations that you'll find, at least some people find, is that when you start reading and looking at OSHA regulations, you start to have some hazardous effects to them. And basically, you start to look a little bit like that. So if you guys start to look like that, we will take a break. Now, there's a few of you already looking like that. Well, we need a break already. So here's what I did. I basically looked at the most recently available OSHA citations between October 2013 and September 2014. I looked at NACIS codes. Everybody knows what that is? North American Industrial Code System, which is put out by the Census Bureau. And they classify companies by different types. So I selected the codes for 31, 32, and 33. And these particular codes cover all manufacturing operations. Okay, so it's all manufacturing. And then I selected a little more detailed code specifically for warehousing and storage. I took all that information and I took the top 10, 15 violations in each of these categories. I put them onto a spreadsheet, and then I totaled the violations, number of violations and dollars of violations for all of these. And then from that aggregate list, I selected the top 10. So, there's a lot of ways to think to make the top 10, right? So I thought I'd tell you how I did it. Then I also summarized the top violations in total dollars. So what are people paying for as opposed to what are people getting cited for, right? So that might be interesting to look at, so we'll take a look at that. And then I also summarized the top average cost per violation. And so what that tells us is if you get cited for something, which ones tend to be the more expensive citations, right? So we'll take a look at that, and interestingly, there's the number one top average violation dollars is not on the top 10 list. So we'll take a look at that. Also, I only included federal citations. So some of you are probably familiar with OSHA, that there are OSHA states, in that certain states have their own OSHA program. To do that analysis, I would have to go through all the 36 states that have state plans, and that was a lot more data than I wanted to crunch. So that takes quite an effort, probably several days of effort to try to get to include all the state citations. So these are only federal citations. And in Pennsylvania, we are covered by federal, so it kind of works out. So how does OSHA decide who to inspect? That's a question for you guys. How does OSHA decide to inspect your work site? What's their number one priority? You know, they're sitting in their office, they're like, what should we do today? I don't know, maybe we should do some inspections. Okay, well, how should we do that? Right? You just open the phone book. Okay, worker complaints is certainly one way that OSHA decides to do inspections. It's not number one, but it is definitely high on their list in terms of importance. Injuries. So yeah, so certain types of injuries OSHA might need to decide to inspect, and we'll talk a little bit about that. There's still, you didn't get number one yet. The most important thing. Okay, well they're inspecting for safety issues, right? So they're looking for problems and violations in their standards. What gets them on their feet? Coming out to your facility, a death. That's actually number two. So if you have a fatality at your workplace, that's their second most important thing to get out on. So what would be more important or more urgent than death?
Previous citations.
That can be definitely a factor, but it's not number one.
Just the industry.
History is a factor. Huh. What's that?
Violence.
Violence. That's a good one. Actually, just as a side note, violence is the second leading cause of death in the workplace. OSHA has no regulations on workplace violence. So hopefully you have policies and procedures in place to address that, since it's the second leading cause of death. Okay, so number one, I'll stop the suspense, is imminent danger. So what is imminent danger? Something that is immediate hazard that could cause serious death, serious injury or death. So if somebody contacts OSHA office and says, it could be an employee complaint, but contacts the OSHA office and says, hey, you know, people are up 50 feet in the air, they're near the edge of the building, they don't have fall protection on, somebody's going to fall, OSHA's going to treat that seriously and they're going to go out on it, and that's going to be their number one priority. Okay, get there before somebody dies. Because when we go to number two, the fatality, people are kind of safe after that happens, right? Everybody's like, wow, we just had a very bad serious accident, we need to be safe. So that actually falls to number two. After that is employee complaints. So if employees contact OSHA, and this has to be a signed complaint. Okay, so the employee signs it. It is anonymous, so the company does not know, and OSHA will not release the name of the employee if the employee wishes it to be kept in confidence. That gets to number three. Beyond that are some of the other things that you had mentioned, and that deals with programmed inspections. So the agency creates a kind of a list of where should we go and who should we inspect based on high hazard industries. So if you happen to be in an industry that tends to have high incident rates, then you're probably going to see OSHA. Construction companies, for example, regularly kind of get visits from OSHA. Barbershops, not so much. Okay, so they prioritize based on hazard. They also have some programs called special emphasis programs, as well as national and local emphasis programs that are focused on very specific topics. So they go out and they say, well, you know, in our particular area, we're seeing a lot of nursing home injuries. So we're going to have a special emphasis program on nursing homes, and we're going to go out and inspect nursing homes. So locally, the agency can do that, as well as nationally, the agency can do that. And I will talk about a special emphasis program in the context of this program today. And then lastly are follow-up inspections. So this is where you already had an inspection, and OSHA wants to come back and see, did you fix the stuff we told you had to fix? Okay. So the problem or the concern with a follow-up inspection is that you can be cited $7,000 a day for every day that you did not fix the problem. So if they came back 30 days later to see whether you fixed it, and you were supposed to fix it 30 days ago, 30 times 7,000 times the number of citations you didn't fix can start to be a lot of money. Okay? So that's kind of how they go about it. All right, let's get to the list. So, I'm going to start with number 10, build up to number 1. Right? So, number 10. Anybody want to take that? So, number 10 is abrasive wheel equipment. You have one of these? If you have a pedestal grinder, something that looks like this, I call these OSHA magnets. When an OSHA compliance officer comes into your facility and they see one of these, they just kind of get, because it's usually easy citation for them. There were 661 violations in the manufacturing setting that I looked at, sector, involving this particular device. In total, there were $718,000 in fines, and each fine was roughly about $1,087. Now, I do have to tell you something here. When I'm showing you the average fine, that's probably understated a little bit, because when OSHA issues citations, sometimes they issue citations without penalty. In other words, you get a citation and OSHA says, you got to fix it, right? But they don't give you a dollar fine. So that gets diluted in here. So the $0 fines are also in here too. So some of these are going to be a little higher. Some of them might actually be no fine in some cases. And those are usually what are called other than serious violations. So what do we need to do with this thing to make sure we don't get cited? Guards. Yeah, so we have some guards. And now actually these top guards, if they're there, they need to be in good shape and in good condition, but they aren't actually mandated by OSHA. So if you don't have to have these, but if people are using the grinder, they need to wear what? Safety glasses and a face shield, right? Both. So you have the option of using these, or you can just go to the face shield and safety glasses combination. All right, so what else are we going to look for on this thing? Yeah, exactly. So the big one is right here. Okay, the gap between the tool rest, it's called the tool rest or work rest, and the face of the wheel. That gap can be no larger than got the good ear out, listening for it. What do you think? Well, how far apart is that? Oh, yeah. So it's 1/8 of an inch. So the problem with this is what? People use the grinding wheel, it gets used up, it gets smaller. So you have to continually adjust the tool rest in as the wheel gets used up. So this becomes an activity that your maintenance department or other people that would be utilizing this type of thing need to pay attention to. The other piece is that this type of equipment needs to be anchored to the floor. This applies to other types of equipment like drill presses and anything else that you got that stands up vertical. Okay? If it has holes in the bottom, it probably means it needs to have bolts in the bottom, anchoring it to the floor and securing it so it doesn't topple as you're using it. So take a look at that. There's also one other provision on here that gets cited a lot because people are generally aware of this requirement, but sometimes are not aware of this requirement. So there's a top peripheral tongue guard that actually comes down over top of the wheel, and that one also has to be adjusted within 1/4 inch of the wheel. So we have these two adjustments that have to be maintained on that wheel for use. Now, why do you think they have those? Why are they important? It's not just about citing you because these things aren't there. There's a reason for them, right? What do you think? Yeah, prevent injury. So what could happen with if you didn't have the work rest adjusted properly? Yeah, you get the work twisted up and down inside there, your hands get down inside there. How about the top guard? Why is that there? Yeah, so that's reducing particle flow out, but also the other thing that's really critical for this type of equipment is if you have a failure of your grinding wheel. So these things turn at anywhere from 4,000 to probably 10,000 RPM, 12,000 RPMs. That's a lot of speed, and if you calculate the surface speed, it's roughly in between probably 100 and 200 miles per hour. So this thing's spinning at that speed. If it disintegrates or breaks, you now have lots and lots of small stones, in essence, sharp shrapnel that's coming out of it that very easily can cause death. So the importance of the face protection, the importance of this top peripheral guard is to prevent some of that material from flying out if in fact you have a failure of your disc. The other thing that OSHA will check is whether you're doing a ring test. Okay? A ring test would be what? Who knows about ring testing?
Tap the wheel, make sure.
Very good. Absolutely. It's a check for cracks. So what we do is suspend the wheel up, and we just hit it with a non-metallic object, such as the back of a screwdriver, and you should hear kind of ding, 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 ding. And if it rings the whole way through, it's a good wheel. If it goes ding, ding, dunk, then you don't want to mount that one, and you want to get rid of it. Okay. And there are situations where people have wheels that are not in good shape and mount them, and they blow apart. I saw a video of a company who actually had video of a wheel blowing up in their facility. But this was no little abrasive wheel. It was one of these ones that are about this wide, about that thick, that just blew. And luckily, the guy had just turned his back right before it blew up. Lots of force, lots of speed in that thing. It's huge. So ring testing is important. So this tends to be a problem for a lot of companies. It tends to be a common violation, as we see, number 10. So how do we fix this? How do we make sure that it's right? Yeah. So a couple suggestions for you, and training is definitely one of them. There's a little distance checker that you can purchase. I think Rockford Machine Guarding, if you're not familiar with them, that's a really good resource for any machine guarding aspects, which we might be talking about later. But they make a little distance checker, lots of places do. So the idea is you try to put that into the one spot, and if it goes all the way in, it's too wide. There's a measurement on each side so that you can kind of use that for the top and the bottom. I also like to post a diagram above this, showing what the distances are supposed to be, right? So that at least people have that information right in front of them as they go to use that piece of equipment. And as you said, train people then on those topics. Some other things is, periodically inspecting, looking to see whether it's being maintained properly, and maybe even giving rewards out, right? We can encourage people by even just saying things to them. And if that doesn't work, maybe beatings, but you might want to check your HR department. So, number 9. What do you think? Well, this one's actually an issue with personal protective equipment. The kind of the thing we think about when we think about safety, right? PPE. So this covers a lot of different stuff. There were 713 violations in this one, $2 million in fines, and the fine was $1,750 per violation. Now, one of the interesting things with PPE is that OSHA can cite this on a per-person basis. And I'll give you the backstory real quick. What happened, well, let me explain this first. So what this means is if you have 25 people in your particular department that are not wearing safety glasses, that really need to be wearing safety glasses, they can cite you 25 times probably a serious violation, so they could go to 7,000 for that. 25 times 7,000. I don't know, what is that? A lot of money, right? So the reason OSHA can do this, and they changed this a few years ago, there was a gentleman down in Texas named Eric Ho. And he started a company called Ho Ho Ho. You can't make this stuff up, right? He had a real estate business, and he purchased an old building that he wanted to convert to apartments. So when he purchased the building, the seller disclosed to him that there was asbestos in the facility. Eric didn't want the asbestos in his building, so he decided to remove it. So he went out, he got quotes for asbestos removal. And they were, $250,000, $200,000, in that range. And Eric said, well, that's a little more than I wanted to spend. Now, being in Texas, he was able to find some people that were willing to work that were not necessarily documented workers. And so he hired individuals kind of under the table, and he said, hey, guys, tell you what, see all this insulation on the pipes and stuff in here? Just get it all out of here. Just rip it out. And but don't start until I leave. So they're in there ripping this stuff out, tearing it out, and so forth. A building inspector comes along, or the building part of the project, and he sees this going on. He goes, that looks like it could be asbestos. You can't just be ripping that out. And there he says, oh, okay, I didn't know that. So he says, we'll stop. He decides that inspector pretty much goes home at 4 o'clock every night, right? Just realized I got 1 second. I realized I'm on battery power, and that's not going to last. Put the rest of the plugs in here. So he tells his workers, he said, well, you know what? We're going to start working around 4 p.m. Come in. We're going to lock all the doors so nobody can come in and see what we're doing. And you go ahead and continue just taking that stuff out. So they get into this old pipe, and they start tearing it off, and they bust the pipe open, and they thought it was disconnected, and it actually had gas in it, natural gas. So natural gas starts filling the building. There was an ignition source, and there's a fire. These people managed to get out and survive. But after the fire response and everything, they kind of figured out what was going on. OSHA got involved, Department of Labor got involved, and they ended up citing Eric for improper respiratory protection, improper training, not having the licenses needed to do asbestos removal, so on and so forth. It was roughly about $1.7 million, a little bit more than his asbestos estimates, right? So Eric said, you can't do that. You can't cite me, because they cited for every single person exposed. Eric said, you can't do that. You can only cite me one time. And he had some good lawyers. And this was always just OSHA policy to cite per person. It was never challenged before. So this was actually, it was an appropriate suit. And he challenged it, and he won. Well, he won. He actually did. He won in the lower court, and then it was appealed. And then they settled. Okay. But before they kind of finished, I guess. But the end state of that was OSHA codified this. So now it's in the reg that they can cite per employee. So what do you have to do? One of the things a lot of companies do not have and need to are these PPE hazard assessments. Okay? You must evaluate the workplace for the jobs and tasks that are being performed for the specific hazards that are in the workplace. Okay. Number two, you have to determine what types of PPE are required for those different jobs, and you need to document the assessment. It needs to be dated, and it needs to be certified. I find some companies say, well, we did job safety analysis, which, by the way, are not required by OSHA at all. But we did job safety analysis, we did job hazard analysis, and it's in there what people have to wear. That's fine. If that can work. But make sure you've dated and certified. The person that did it has to date it and certify it. So that's what I see missing sometimes. In addition, the findings of this have to be communicated to employees. Okay, so what did you determine was necessary? And then it needs to be reevaluated periodically. OSHA has not specified you have to do it every so often. They suggest every 5 years at least it should be redone, but there's no specification on that. If you have changes in your workplace, you should redo it. So here's an example of a form for that hazard assessment. So what's the task or activity? What are the types of hazards we're exposed to? What type of PPE is going to be required for that specific task? So that's the form, and then you would date and sign it, so something like that. So people need to also be trained on their personal protective equipment, right, so that use it properly. You might notice this particular woman has her face out the neck portion of the helmet. It might work that way, I don't know. So if we don't train people, we can't expect them to use their stuff properly, and with that, OSHA has very specific training requirements. So, what do people have to be trained on? And this is one I find missing in a lot of companies. Number one, you have to be trained on when PPE is needed and what is needed. You also have to be trained on how to properly don or doff, or put on and take off, adjust their PPE, the limitations of it. These are low impact safety glasses, so you can't use these for grinding. Okay? These steel tip shoes are rated 30 pounds for impact and compression. So, they're not going to handle a heavy load. Your hard hat or your bunk cap is not going to handle, something dropping on your head. It's for bumps. People need to understand what the limitations are of the equipment that they're using. How to care for it, maintain it, clean it. What's its useful life? Can I wear this thing for 20 years? Or you got to change it out every 3 weeks? How do you dispose of it? And then this is the part where people get in trouble. Each affected employee shall demonstrate an understanding of the training specified above and the ability to use the PPE before being allowed to perform work requiring it. So how has your company demonstrated knowledge of the PPE elements listed above? So there's two ways to do that, I think. One is to actually have the person do it, demonstrate it, and document it that. Or you can also supplement that with a little quiz after you do your PPE training to show that they have a demonstrated knowledge and understanding of the topics. So it's not just enough to train people in PPE. You have to have some validation that they understood it. Okay, so what documents do you have in place to validate that? Number 8, any questions on PPE? There's a lot in there, a lot of stuff in the PPE standard. Another one, just to digress for a second, in the PPE standard, that I find is people in maintenance departments doing electrical work, and they have the insulated electrical gloves. Every 6 months, they have to be sent out for dielectric testing. Okay, to make sure that they're still protected. That's what I find a lot. Number 8. This is power transmission apparatus guarding. So this power transmission is basically transmitting power right through a system. It could be through gears and pulleys and belts and things like that. So it's transferring the power. So there were 1,092 violations in that category, $1.7 million in fines, and the average fine was $1,600. So what are we looking at? Shafting, flywheels, pulleys, belts, chain drives, and so forth. If they're less than 7 feet from the floor, they have to be guarded. Now, what do you think about that? Less than 7 feet from the floor, you have to guard it. That means anything 7 feet above, or above 7 feet, you don't have to worry about it, right? Not from a compliance perspective. How about from an injury perspective? So it's very often people will set a ladder up to go do some work, and I don't know about you, but I'm not that tall of a guy. I don't know if I can get to 7 feet or not, but I might be able to. Right? So this may not be 7 feet may not be out of harm's way. You still may want to guard and protect things that are beyond that. All right. The other piece to this is that OSHA requires inspections of power transmission equipment and guards. That's one I find missing a lot. Okay. So basically what it says is power transmission equipment shall be inspected at intervals not exceeding 60 days. And it must be in good working condition at all times. So I would suggest OSHA does not mandate that this be documented inspection. But again, you don't have a document showing that you've done it, It's kind of between your word against theirs, so to speak. Okay. So this would be appropriate to document. Inspection shall be made of the belts, lacings, fasteners, and all this equipment needs to be kept in good repair. So here's some examples of some other types of power transmission related aspects in guarding that I think probably get cited pretty often. So here's an end projection. Right? You might have this on some sort of conveyor system or other type of equipment. You have the end projections of the shaft sticking out. Okay? The most it's allowed to stick out on this is 1/2 the diameter of the shaft. So this one, you know, that's the half the diameter. That's as far as it would be allowed to stick out. If it sticks out any more than that, you have to cover it. It must be guarded or protected. And so that's another one people have issues with, right here and here. And I put the actual standard in here because I find humor in how OSHA writes things sometimes. So I thought this was kind of funny. So just listen to what it says here. Projecting shaft ends shall present a smooth edge and shall not project more than 1/2 the diameter of the shaft when started by a non-rotating cap or safety sleeve. You hear that? Smooth edge and. So that's power transmission. Number 7. General electrical hazards. There were 1,214 violations with this, $1.7 million in fines for this topic, and roughly $1,400 per violation issued. Now keep in mind, I mean, violation dollars can go, as I said, from $0 to $70,000 per violation, depending on how it's classed. So, anything over 50 volts has to be guarded or protected. If you have a circuit that operates at 50 volts or greater, it has to be covered or protected. It cannot have open conductors. In addition, all the electrical safety work practice requirements kick in at 50 volts. So these are the types of things we find in workplaces where there's covers missing, there's openings in the boxes or materials. You got these knockouts that are typically found in panel boxes, typically found in outlets. They all have to be in place, otherwise you have exposed electric. I remember many, many years ago when I was a safety specialist in our company and was doing a safety audit along with my supervisor, who was the corporate manager of safety. And he saw a panel box right about this height. And on top of the panel box was a small brass fitting. And it's a fitting that goes on top of oxygen acetylene lines to cap them. I don't know if those or not. It's just a little brass fitting. Oftentimes they have a little metal chain that is attached, sort of like the light pool chains. So he saw this little metal cap sitting up there, and he proceeded to say, well, that shouldn't be sitting up there. And he reached up to grab it. And as he did, he lifted it up and he saw that there was a chain on it, and that the chain was draped down and it was inside the box through an opening in the top of the box. And as soon as he picked it up, he realized what he was holding on to. So that chain, if it touches any conductor inside there, he's done. So he had the choice of either to drop it or to try to take it out. And he said, I'm going to pull this straight up. He goes, be ready to do CPR on me. And he did. He was able to pull it straight out and pull it out. But, that's an example. You have openings like this, stuff, electric can come back out. Something as simple as an outlet cover, right? I was in Tennessee doing a compliance audit for a company, and I walked into the safety manager's office, and that was the outlet. It's like, really? I can't wait to see the plan. All electrical equipment that's brought into your facility has to be listed or labeled. What's that mean? Listed or labeled. OSHA has a requirement that all equipment be approved by a national recognized testing laboratory. For the most part in the United States, that's UL. Right? So pretty much any piece of equipment that you have in the workplace has to be approved by UL and has to be used in accordance with its listed or labeled use. Here we see an extension cord of sorts. Do you think they got that at the Home Depot? Parts of it, anyhow, right? So, what's the issue here? This is not a listed or labeled device. Now, extension cords actually can be manufactured in-house. You can build your own extension cords, provided all the individual components are listed or labeled, and that you assemble them in accordance with their listed or labeled use. And the only reason that's allowed is because electric extension cords are considered temporary electric, which is allowed to be a class less than that of permanent electric. So therefore, you're allowed to build your own and not have the whole thing approved, but you have the individual parts approved. Okay? The problem with this is when people use these types of boxes, usually these types of boxes are designed for what? Stationary mounting. They're designed for wall mounting or something like that. This is being used in an application it's not designed for. So it's a violation. And OSHA will cite that. Not to mention that typically, that's probably too many outlets. We also have lots of times find issues with panels. So what are we looking for here?
Labeling.
Okay, so they should be, ideally should be closed so they're not in use. Labeling.
Labeling.
Right. What controls what? Right. So
Power,
we know exactly.
power for the different areas.
Yeah. So this should all be clearly labeled. Some of these I look at, they're in pencil, and they've been there for so many years you can't even make it out anymore. You know, I have a labeler that I labeled all mine in my house. You don't have to go that far, but it should be very clear as to what controls what. What else do we need to have here? Sometimes do this. Yeah. So oftentimes these are unused sections, right, for future circuit breakers. And sometimes we'll find where the little cover for those is missing. And then you have exposure to electric. So it's very important that you open these things up. They should be all sealed up. You shouldn't have any way to contact electricity. All right? So those are the big ones for panels. Also, on panels, on the front of a panel, it has to indicate the voltage. And equipment that you have in your facility should have some kind of nameplate indicating what voltage it runs on, what amperage it draws, information as it pertains to that particular system, so that you can make good decisions about what's there and what you're dealing with. So nameplates, electrical nameplates or information plates, both on panels as well as equipment, really should be in place.
Those have to be in front of the box.
Yes, on the box, typically too. So the voltage is what you're looking for on the box. And then the one that we always have problems with is these panel boxes getting blocked. Okay, so there's a requirement for 3 feet clearance in front of all boxes, panels for access, and in some cases, depending on the voltage, it's 4 feet. So how do you guys make sure people don't put stuff in front of a panel box? Put caution tape on the floor? Yeah, so if you put some caution tape right in front of the boxes so that it shows exactly where to store things.
You have to shut the
Right.
box and that's probably going to be in the middle.
Right.
Remove it, you have a nice place clear.
Yep. So, that can be an issue, and why is that an issue? Yeah, you might need to access it in a hurry. So, a quick story, I read a fatality not too long ago. And this involved 2 guys doing work in a home, residential property. And they were fixing the old garage door opener. Right? Now this is the middle of the summer, August. If you get up into the roof system on a building in the summer, what does it tend to be? Hot. Right. This individual sets up an aluminum ladder, climbs up there, and he's going to do a repair on this overhead garage door opener. Now, he has a short sleeve shirt on, and he's sweating. So we know when we sweat what happens to our bodies as it relates to electricity. It's much more conductive. Our body's resistance drops by 500 times. So he's up there, he's all sweaty, and he's doing a small adjustment on the overhead garage door. Now, that comes in 120 volts, and usually they're plugged in, right? So you just unplug it. But this was direct wired into the house. He's making a small adjustment, and the 120 volts come in. It has a step-down transformer, it goes down to 24 volts typically. 24 volts really isn't going to hurt you too bad. He's in there making that adjustment, and his arm comes down on the primary 120 volts. His buddy says, "That's not good." He goes into the house and says, "Where's your disconnect box?" It's down in the basement. He goes running down in the basement. He sees the disconnect box, except you can't get to it because there's stuff stored in front of it. So now he's moving boxes, lifting things, moving, getting all the way over there. Flips open the box, and of course, he looks at the breakers and nothing is labeled. So what do you do in that case?
Hit the main.
Turn them all off or hit the main, right? So he hits the main disconnect. All the lights go down out in the basement. Now he can't find out where he's going after he just moved all that stuff he's stumbling over. He finally gets back to his buddy in the garage, and of course then it's too late. So the point of that is, the labeling, the access, but also we want somebody to be nearby if electrical work's going on so that they can respond and know where to do the disconnect. Here's another one. This one is, they built a structure in front of the box. So this infringes upon that 3-foot clearance, minimum clearance requirement, and is a violation. All right, so that was electric. Any guesses what the next one is? Number 6. Well, guess what? It's kind of the same thing. More electrical hazards. So this is just a different section in the regulation. The first one, if you want to know where it is 29 CFR 1910-303. This one's 29 CFR 1910-305. But it covers a little different things. So in this particular category, there were 1,461 violations, and the fines were $1.8 million. Average fine was $1,262. Okay, so what are we talking about on this side of electric? One of the biggest problems that we run into is use of flex cord. Flexible cord is generally only permitted for temporary applications, with these exceptions that I have up. Number 1 is a pendant or fixture wiring. So you are allowed to drop a flex cord from the ceiling. Okay. Typically, for lighting, you can do it where it's directly into the box. If you're dropping it for an outlet, you really should have a plug going into an outlet receptacle at the drop with the string release. Portable lamps, tools and appliances that are movable, you can use flex cord for that. And if you have stationary equipment that you need to move around occasionally in your facility, you are allowed to use flex cable for that, also to isolate vibration. Okay. Other than these permitted uses, the only other permitted use is temporary as an extension point. So there's a lot of times people use flex cable when they flexible cord when they should not be using that. Extension cords, again, shall not be stapled. They should not be fastened to the building surface. They cannot be hung from nails or suspended by wires. These are temporary applications. So what I find is somebody plugs something into the outlet, they run it up the side of the wall, they put a few wire ties there to the conduit, they put it up over the drop ceiling, they run it over here, they put it down and plug in a clock. What do they have to do? Put permanent electric in. You need an outlet over there. Install one. Don't use flex cord. This particular one I found, I found at an institution of higher education that, or went to school. It's really surprising. And you know, I said, that's not really good. And they were like, oh, okay, yeah, we probably should get rid of that. We should. So flexible cord has to be rated and listed, again, for the application it's being used in. So a lot of you, you think about the cords you have in your house, and you have a lamp cord that runs to your lamp, and it has two conductors, right, and it's flat. And we call that zip cord sometimes. That cord is absolutely not appropriate for an industrial environment. So we have to make sure that the kind of cord we're using is the proper type. So what you want to look for are the letters on the cord. If it doesn't have any letters on it, then it's probably not a rated cord and you want to get rid of it. Or it's an old cord and it wore off. But you want to look for the S or SJ. Okay, S is hard duty, SJ is junior hard duty. So those two cord types will be good for a heavy environment, either construction or manufacturing setting. If it's not of that type, you really probably shouldn't be using it. Now, there's lots of other letters that you'll see on a cord. So I'll tell you a couple others that are important. You may see others beyond this. Okay? Another important one is the O. O stands for oil resistant. And if you have two O's, it's double oil resistant. So it means the outer insulation and the inner insulation is resistant to oil. So you might want to look for that if you're using it. Another one to look for is W, which would be what? Weather resistant. So if you're going to be using your cord outside or it's going to be exposed to outside conditions, then you want to make sure it has a W in it. So something SOOW would be a pretty good cord for a lot of applications. So just be aware of that. There's lots of other letters that you might find in there. But those are some key ones.
I have a quick question.
Yeah.
Does OSHA give a definition of temporary?
Yeah, they do. In one section of the regulations, they talk about temporary being 90 days.
Okay.
And they specifically refer to it as decorative lighting in that aspect. But that's kind of a guideline they tend to use. So here's an example. They put some flex cord, wired it directly into the box, brought it up here, hung it on. This is another rather heavy-duty cable. Whether it's being used in an application that's a permanent application, I don't know, but the question would be where that's going and how it's being done. Another aspect to this is really just guarding, or not guarding, but grounding. So here I have kind of a diagram of a basic electrical circuit. And we have the black wire, which is your hot, your white wire, which is your neutral, and then your grounding electrode, which grounds the circuit in the event of a problem. So, of course, electricity is just movement of these electrons, right? They just jump from one atom to the next, and that's electricity. And some things it's very easy to get the electrons to move, and those are conductors, and then there's things that it's hard to get them to move, and those are insulators. So without getting into much discussion of alternating current versus direct current, these electrons are basically coming out of the hot wire, doing their job. They go through a load, do their job, and they return back through the white wire, which is connected to ground. So the way I like to think about this is ground is home. So the electrons go to work, they do their job, and they go home. Right? They like to go home. You guys like to go home at the end of the day? Yeah, depends what's going on at home, but yeah. Usually we like to go home at the end of the day. So they're always looking for an opportunity to go home. Now, what can happen is we have a short. The hot wire comes off. It's now touching the case of the tool. Right? So what happened basically is these electrons came to work and they couldn't do their job. The gate was shut. They couldn't get into the plant. So if you go to work and the gate's closed and you can't get in, what are you going to do? You're going home, right? You're not going to just sit there and wait for 2 hours, see if they open up. You go home. Electrons want to go home. They can't go home this way that they normally would go home. They can't get there because that's through the plant. So what are they left with? They're looking for another opportunity. Well, look, this is connected to here. Hey, we can go home this way. We'll get home this way. The road's just as good. Look at that. We got home. Yay! Unless, of course, you decided that you needed one of these. One of those little cheater plugs, you put on, you go down from 3 conductors to 2 conductors. Or maybe you just break off that third prong because you really didn't need it, and you're plugging it into that little chintzy extension cord. It doesn't take a third prong, so you had to break it off to get it in there. You took away your safety. Does the tool still work if you break off the third prong? Absolutely. You just the only thing you did is just took away your safety. So these, by the way, are illegal in the workplace. Grounds have to be continuous and permanent. You can't take it away. Okay. Now there's this little wire that's on here, right? You're supposed to do what with that? Hook that to the outlet, right? So I've never seen that done. And the other question comes up, is that an effective ground? Right? Is even the outlet ground? Is it is the connection problem? So even at home, you want to make sure that if you are going to use those, that you do connect that third piece. And better yet, put it on what we're going to talk about next, and that's the ground fault circuit interruption. So you're holding onto the tool. You broke off the third prong. You got one of those cheaters in. The electrons want to go home. You took away the extra road. So what road are they going to take? Yeah. This is the only road they got to go to home. Now it's a bumpy road. It's not a very fast road. It's tough to get down through it sometimes, but hey, it'll work. We'll get there. And then if you're holding onto the tool, you're getting shocked. So OSHA requires that there be grounds on hand tools, that there be grounding conductors on your extension cords and so forth. So these are just another piece that people get cited for is poor grounding situations. Also, GFCIs. Now, most of you are familiar with these, I'm sure. GFCIs, ground fault circuit interrupters, are wonderful devices that help protect us from electrical shock. And of course, you see these where? Where?
On computers, stuff like that, on the computer.
You might see on computers. They don't really need to be on computers. Your kitchen, yeah.
That's where I have them.
Yeah, you got them in your kitchen. You got them in your garage, maybe. All your outside outlets should have these types of outlets on. So GFCI is anywhere there's water present or has the potential to be present, you should have GFCI in place. So that can be a violation. The thing, how these things work is really cool. And they're really great. So here I have the hot wire, and then I have the white wire, right? So here the electrons are coming out. They do their job, and then they're supposed to go home. Now, the GFCI, the way I like to think about a GFCI, is it's kind of like a parent, right, of like teenage kids. So my daughter's 23, I think, 22. I have a son that's 20 and another son that's 18 or something like that. When the birthdays come around, I've got to figure that out. But so the parent sits here, right, and he watches, and the kids go out and they do stuff. I don't know what they do, right? And then they're supposed to come home. So when they leave, you say, well, why don't you try to be home around like before 1 o'clock in the morning, okay? Get home before 1 in the morning. And then you watch, right? And if they don't come home when they were supposed to, what do you do?
Search for them.
Well, it depends. So if it's the daughter, the first daughter, yeah, you search for them. If it's the boys, you lock the door and go to bed. But when they finally do get home, what do you say? You say, you're grounded, right? you're not going out anymore. And that's exactly what a GFCI does. If the GFCI finds out that it can't account for the electricity it's sending out, it's not getting all that electricity back, it opens the circuit. It stops sending electrons. It does that in a 40th of a second, protecting the other individual, or the individual from shock. So these are wonderful devices. What it does is it looks for a loss of what's called 5 milliamps of current. So that's 5/1000ths of an amp, which is not very much, but it's enough to cause us to feel a tingle, a shock. So it interrupts the flow of circuit before the point where it becomes dangerous. So, where else does OSHA require these besides water areas? These are required on all temporary cords, extension cords, used in maintenance and construction applications. So if your maintenance department is running around with extension cords, they better be plugging them into a GFCI outlet. Or using one of these little things. Right? As the GFCI built in, I can plug it in here, I plug my extension cord in here, and now my extension cord is protected. Okay? So, we're halfway through the top 10. So that might be a good time to take a little stretch if you guys want to take a little stretch, get some food and coffee or what have you. I'll continue with the up to number 1. We got 5 to go. What do you think's out there yet? What did we talk about that's probably a big citation? Flammables. Yeah, maybe. Machine guarding? Yeah, I kind of alluded to that. That's coming.
Lockout, tag out.
Lockout, tag out. That's going to be in there. How about what else? Forklifts might be in there. HAZCOM. Yeah, okay. You guys already knew what they were. You didn't have to come. And surprisingly, this list doesn't change a whole lot. You know, I do top 10 for the past 20 years. It's kind of like, same thing. You know, they change positions a little bit. You'd think we'd be able to get this stuff right after a while, right? Let's go check. All right, let's take a look at number 5. I think somebody said power industrial trucks. And by the way, for those of you that may be in warehousing, this is number 1 for you. Okay, surprise. 1,683 violations, penalties of $2.1 million. Fine per violation is $1,253. Something to keep in mind that power industrial trucks does not just include forklifts, it includes anything that has a motor or power and moves, tiers, stacks, or handles materials. Okay, so that includes your electric pallet lifts, and anything else. The other thing I see, you know, if you have golf carts that you use in your business or little maintenance carts, they can actually be considered to be covered under here, depending on how you're using them. So what's required, obviously operator training. I think most people are familiar with what's required from an operations perspective as far as training goes. You essentially need to make sure that each operator is competent to operate the power industrial truck safely as demonstrated by successful completion of training and evaluation specified in the regulation. So just to highlight a couple things. Number 1, anybody under the age of 18 is not permitted to operate a power industrial truck. I just ran into that recently. I won't give you the details of that, but anyhow, I want to make sure that people are old enough to actually run them. You may even think about creating a higher age limit than 18. I'd probably be in support of that. So what does training consist of? You must do 3 things in your training. You must cover a classroom session. This could be lots of different ways. You could use a video, you could use online materials, you could do PowerPoint, however you want to do it. There are very specific topics that have to be covered in your classroom session. It has to include equipment-specific topics. Okay, so what specifically on the equipment, you know, the details of how that equipment operates and works.
How many HP power they have?
Yeah, so what's the capacity of the particular equipment they're going to be using? How do they determine that? How do they determine the load weights of the items they're going to be picking up? All that becomes very important. Workplace-specific topics. So your training has to include things that are specific to your workplace. So we have this ramp out here. It's more than a 10% ramp. You have to actually back up it when you're empty and go up it forward when you're loaded. We have low overhead clearance over here, and our triple mast lift will not go under there. When it's elevated, you have to give them specific details about your work environment and things that they need to be aware of. And then finally, you have to cover what's specified in the OSHA requirements and give them an understanding of the OSHA requirements. Within this classroom session, OSHA is specific about other topics that are covered. For example, you have to talk about how a forklift is different from a car. Okay, specifically. And I have a whole activity I do about that. So there's content there that has to be covered. I have had people call me in the past say, hey, we got a new forklift video, meets all of OSHA's requirements. I'm like, oh, really? I'm really interested because I wondered how you would incorporate the lifting devices we had in that video and the specific workplace topics in our workplace. Yeah. So, that's kind of a question. You can certainly use a video, but you need to supplement it with these other things. Number two, you have to have a hands-on training. Okay, this is where a qualified operator or trainer works with somebody to develop their skills on a hands-on basis. This is probably not done in 15 minutes. Okay, you need some time if you haven't run forklift before to get comfortable with that. It steers differently, it works differently. You need to get comfortable with the skills. That hands-on training has to be done in an area that is safe. Safe for the trainee and for other employees. One company I saw, it was really nice, they had the space. They blocked out probably an area the size of this room or a little bigger as their forklift training area. And so the operators would just do their training inside that frame, which was really nice. So that hands-on has to occur. Lastly, we need to do an observation of the individual's performance. So OSHA will need to assess your training materials and determine whether you're doing all of these things appropriately. Okay. So what I would suggest is for the classroom portion, you probably have some sort of quiz or test that demonstrates the content knowledge that you presented in the class. Your hands-on, what I like there is a training log. Log the hours of the time the person ran, the trainer, observer, kind of saying, they assigned what kind of activities did they do, high-tiered some materials into the top shelf, or move the box from one location to another, what kinds of activities were involved in the hands-on. And then lastly, your observation. So using an observation form. Did the person use 3 points of contact getting on and off the lift? Did they wear their seatbelt? Did they sound the horn at blind intersections and corners? Kind of check all that off, and you sign and date it. So those kind of 3 documents together would provide a very good documentation for OSHA that you're in fact covering these 3 aspects to your training. Refresher training. How often do we need to train people?
Every 3 years or when you get new equipment.
Okay, so right away in this case. That's all. So if you see somebody operating unsafely, you must retrain them. If you have an accident or near miss involving a forklift, you must retrain them. If you evaluate their performance and you determine that they aren't doing everything the way they should be, you have to retrain them. If you have a different piece of equipment that comes into your facility, they have to be trained on that piece of equipment. Now, this does not mean if you have an LPG forklift truck and you send it out for service and you bring another LPG forklift truck in that's a different model, you don't have to retrain them all over again. But you do have to orient them to the new equipment. If you go from a sit-down to a stand-up, that's very different in terms of how it operates and the hazards and so forth. So you do need to retrain somebody in that case. If a workplace condition changes such that it introduces a new hazard into the workplace, you have to train them on that new hazard. So that, let me get back So this is the list of when retraining is required. There is no specified frequency for retraining. There is a specified frequency for this, evaluation. Evaluations have to be done every 3 years. So a lot of companies choose to do the training every 3 years. Fine. Whenever you do training, you always must follow it with the evaluation portion. So if you choose to do the training, you can, however, just go out every 3 years, take the inspection form, monitor the person, check them off, that they're operating appropriately, sign date, and put it in the file, and they're good for another 3 years. How many of you have a forklift license? Okay. So OSHA doesn't require a license. They require a document. So it could be in the file. It doesn't necessarily have to be a card that you carry with you. That's an easy way to do it. It's a way to keep an eye on when that 3 years is coming up, that you need to get a new card. But that's kind of the OSHA's requirements. So, I kind of just. So typical violations that OSHA will cite: seatbelt. It's actually not in the reg that you have to wear a seatbelt, but OSHA does require it. They put it under what's called the general duty clause. So, and why is seatbelts so important for forklift operators? A bunch of you are operators, you should know this. Why is the seatbelt?
Tip over.
Yeah, tip overs. The number one way people die in forklifts is a tip over event. When you tip over, you fall out, and then you're crushed and killed by the overhead guard. If you have your seatbelt on, you don't die. So that becomes a very important part of safety. I'm a stickler. If I don't see somebody wearing a seatbelt, it really bothers me, because I know what can happen. Parked with the forks elevated. And we're not usually talking about somebody who lets their forks up like this. We're usually talking about somebody that does this. They just have it a couple inches off the floor, or they don't have them tilted down all the way. And becomes a tripping hazard. Speed, right? So a lot of companies put governors on their equipment. This is a very subjective thing. OSHA does not have a speed limit. It kind of depends on the conditions. I mean, you're out in a clear space, you can see all around you, you can floor it. Except for the bumps, because you don't have shocks. But you're inside working your people, you have to go very, very slow. Traveling with an obstructed view, right? People don't see what's in front of them. Sounding the horn at blind intersections and corners. That saved me one time. I heard the beep and I stopped. And I was glad I did. If he had not beeped, I would have been run over. Overloading. Positioning themselves under the forks or getting people into the fall zone. The fall zone is what? Yeah, it's anywhere, if you have the load up here, if it falls, where's it going to go? There should be nobody there. Or worse, you see people elevate the forks with a load or something, they can go underneath to do something on it. The forks above their head. Not looking in the direction of travel. Where this comes into place the most, somebody goes, they drop a load, boom, they start backing up, and then they look. They've already traveled 6 feet before they look.
What about when they don't have the sound in the back, when they go reverse? How is
A backup alarm is not required by OSHA. Okay? You can include that, which would provide some warning potentially, although I'm very intimately familiar with an accident where an individual was run over and both her femurs were broken in her legs, and the forklift did have a backup alarm, but she was so close to the forklift she didn't have time to react. So, but backup alarms are not a bad idea. You have to consider that contributes to noise and whether that's appropriate for your environment. Unsecured loads falling off of the forks. And then the thing that we like to use these for are elevated personnel as an elevator. OSHA does require a pre-shift inspection. So each shift there should be an inspection done. Technically, the reg doesn't say this has to be documented. However, once again, if you don't have the document, then it's going to be between you and OSHA to decide whether the inspection's actually been done. So I would encourage you to have some sort of written document for this. But doesn't specifically say that. If there's a deficiency, it has to be taken out of service. That's a huge one. That's
If you have 3 shifts, they have to check before each shift.
correct.
I have another question about that. We have some vendors sometimes that come to back door, like to bring some things, and they'll just grab a forklift and unload. Now, if they are carrying a cart that they were trained, do they have to be trained specific on our forklifts?
Yeah, so OSHA has a letter of interpretation on that. And basically, there is an obligation by the host to make sure that those individuals are trained
On our
And-
equipment?
on the equipment that they're going to be using. So if, for example, they are trained as a forklift operator on sit-down equipment, that might be adequate for what they're doing. But you have to assess what their training is and determine whether it's appropriate for your work environment. The other piece to that, and I know it's a very practical thing to do, but the other piece to that is the liability, which is a whole other question. So if they end up getting hurt using your forklift, there's some potential issues there for liability. So
My insurance broker is.
you may want to have your insurance broker work with you to come up with a release, some sort of release or something that would be a contractual risk transfer to transfer the risk to the other party to the extent possible in your contract documents. So this is just an example of obstructed load. This is actually a picture from a fatal case where an individual was standing in front of this, and the forklift operator just basically ran her over and was not able to see her because of the height of the material here, and actually drug her for some distance before you realized what had happened. So the other thing to keep in mind on forklifts, it's the employer that certifies. So the only reason I mention that is because we do training for forklift operators sometimes, and lots of other companies provide training for forklifts. If you have another company coming in and doing that, you need to either co-sign the certificate or the card or whatever you're getting, or create a document that says we certify these individuals. Okay, so it's the employer is the one that has to actually do the certification. You can't have a third party certify the people in your company. And you can have them do the training, although I don't think that's the best approach, right? Because think about it, every time you have a near miss, an accident, new equipment, you got to bring somebody in to do the training. And it's probably better to set up your own class, your own program. The other thing I just mentioned too, now when I'm ahead. Man, when that happens. Get old, not so far. I had this idea. It may come back. It may not. It comes back. The employer certifies, creates some sort of document certifying that the person has been trained. And that can be in the file in the office. It doesn't have to be in the person. Some other just quick tips. Train pedestrians. We spend all the time training forklift operators. We do nothing to train pedestrians. Pedestrians are huge exposures. Train them on where blind spots are, not only in the facility, but on the forklifts. You're looking through the mast of the forklift, and depending on the forklift type, you could have significant blind spots. Somebody could be walking at the same speed as the forklift is traveling, and they'll never see them, and the forklift operator will feel like it's perfectly clear, because I've been traveling, I haven't seen anybody. And in fact, they're just in a perfect blind spot with that person. The rear end swing, right? On a sit-down forklift, the rear end swing of a forklift, because the rear still turning, swings very quickly and very rapidly. Pedestrians should be aware of that, how they could be struck by that, what the fall zones are, and that there's a prohibition of riders. Also, try to design your facility to separate vehicle traffic from pedestrians whenever that's possible to do. Okay, it can be physically separated. In one facility we were building, they were going to have the personnel traffic in one aisle, and right beside it, forklift traffic. And there was no delineation between the two. So you'd open the door and you'd be in the pedestrian lane, and then another step you're in the forklift lane. So we ended up putting a physical, solid bumper whole way down through the facility to physically separate those pieces. So when you can do that, that's the best approach. If you can't do it physically, at least do it with some lines and designated walkways and so forth. Mirrors, other controls that you might look at putting in place. Train your supervisors on forklifts. Okay, they might not need to use them, but they have people in their areas that are using them, and they should know what the hazards are and what needs to be addressed if there's an operating issue.
Question,
Yes?
skid loader, does that fall under forklift?
So a skid loader that is not designed as a forklift is designed, so when you say a skid loader, do you mean like a Bobcat? Okay. If you mount forks on that, and in essence it becomes a forklift. OSHA says because it was originally designed as an earth-moving equipment, we don't consider it to fall under the power industrial truck standard. It's a their interpretation. So no, you do not have to treat it the same way. Should you? Probably. All right. Number 4. Respiratory protection. 1,848 violations, and we had $1.2 million in fines, and the average fine was only $674 for a violation. So this one is a lot of violations, but not usually terribly expensive. How many here have respiratory protection use in their facility? So you want to make sure, number one, that you're selecting the proper respirator for the exposure. So it'll be protected for a while. So when are respirators required? When do you have to put one on? Well, I'll give you some options. How about if it stinks? Oh man, ugh, it stinks in here. Woo! I need a respirator, right?
It's optional now, right?
Huh?
Isn't it optional if it's obnoxious fumes, but not above the PEL?
Yeah, so if it stinks, that doesn't really tell me anything. It tells me it stinks. It might tell me something if I know what the odor threshold of the chemical is and what the allowable is.
How's this wrong?
What's that?
How's it first? Got this off for, wait,
You're having one of those moments I had.
yeah, I know where how to say it.
So odor is an indicator that something's there. It may or may not indicate that you need a respirator. How about if you're not feeling good? It's like you work in that area and you're like, need a respirator? Maybe. Maybe you should have had one on a long time ago. How about if you're feeling good? Hey, might be an indication. Might be an indication. You're a little too happy at work. How about if somebody tells you, that's really bad stuff? Maybe. How about if you see lots of little particles floating around? Maybe. So really the answer is when safe levels are exceeded. So OSHA has levels of allowable exposure. They're called permissible exposure limits. And we usually don't like to use these because these were made in 1970, most of them. And today we have more knowledge about chemicals and their hazards, so we use typically a thing called a threshold limit value as to the allowable exposure, which is the current science. So this is the current science behind what people can be exposed to, and this is the law to what they can be exposed to. And there are occasions where this may be 10 times lower. Current science is 10 times lower than what the law is. So these are limits. If you exceed these limits of exposure, then people need to be protected. Of course, with all PPE, it is the last what?
Last resort.
Yeah, kind of. Last line of defense. Right? So all PPE, including respiratory protection, is the last line of defense. It's the last option to protect people. So if we end up in an assessment looking at something and say, well, you need to put respirators on people, that means either we didn't do a very good job, or we went down through every other possible option, and the only thing we could come up with was to put a respirator on the person. Okay. Once you get above those levels, though, you have to protect. And these are measured in parts per million, milligrams per cubic meter, or micrograms per cubic meter, fibers per cubic centimeter, or other types of concentration measurements. So that's a whole other topic, we won't get into that. But you need to select a respirator that's an appropriate respirator for the exposures that you have. So we have this type of respirator, which is supplied air. Okay? So we're actually bringing in, it's called Class D air, into the respirator and providing fresh, clean air for people to breathe. And then we have air purifying respirators, such as your cartridge respirator, where you're just taking the outside air and you're trying to clean it. So which of these two would be the most protective? Something that has fresh air coming in or something that's cleaning the air? Right? Fresh air. So if we're blowing fresh air in, we're getting, hopefully it's tested, checked air. This has to be tested or checked on the way in. But this is clean air. And this has a limitation. It can only filter so much. Right? So if you have oxygen deficiency, it's not going to help, right? You don't have oxygen in the air, it's not going to add oxygen. So that's going to be a problem. So there's limitations on both of all these types of respirators. So it's not permitted for an employer to say, hey, it's kind of smelly back there. You should probably wear this respirator and just hand me a respirator. I have to know as the employer, what's the exposure? Because I need to know which respirator to give you. Right? Do I need to give you a little dust mask, or do I need to give you a cartridge respirator, or a full face, or air supplied, or what kind? So it's required that you have an understanding of what the exposure is in the workplace in order to make that assessment. This means that you need to either have industrial hygiene surveys completed that have measured that. In some cases, we can do exposure modeling. So if we know how much is being used, we know the characteristics of the chemical, we know the room, we know the ventilation systems, we can calculate what the likely exposure is to somebody. That little exercise usually is as expensive and sometimes more expensive than just actually putting a pump on somebody and measuring it. And then it's oftentimes not as accurate. So we usually don't use exposure modeling unless it's no other way to do it, or it's a very simple scenario where we just want to get like a max of what it could be. You may also use similar survey data. This could be from other companies or from other applications where somebody has done some studies and has determined what the exposures are, and they're relatively comparable to your situation, that you can say, well, we're probably within these ranges of these exposures assessments that were done in other applications. So you really should have some sort of documentation of when people are wearing respirators as to what they're exposed to. If you do not, OSHA says you have to assume it's ideal age. Ideal age. What's that?
Immediately deadly or hazardous?
Yeah, immediately dangerous to life or health. So you have to assume it's worst case scenario, basically, which automatically puts you into air supplied respirator. Okay, so now you got the hose line coming into your respirator. And you have to have an escape bottle in case the airline hose gets cut off, so you can open your escape bottle and get out. Okay. So if you assume that, you're into some pretty heavy stuff. So what do? Respirator approvals are done by NIOSH, the National Institute for Occupational Safety and Health. Only approved respirators are permitted to be used. A lot of people use these particulate respirators for dusty environment, something like that. And there's 9 different classifications of these, which I have listed here. You'll notice that there's P's, there's R's, there's N's, and then there's 95s, 99s, and 100s. The number refers to the efficiency of the respirator in filtering out particulates of a particular size. The letters refer to whether the respirator is oil-proof, oil-resistant, or not oil-resistant. So if you're using a respirator for a grinding operation where there's also oils, cutting oils present, and I want to be protected to the very best level I can be using this type of respirator, which one would I select? These are the 9 choices you have. So I'm using a grinder, I'm generating particulate, I have a oil mist in the area from other operations, and I want to be protected to the highest possible level that I can do. P100 has to be oil proof, and at 100%, it's actually 99.99% efficiency of filtration. A 95 to 100 is not a lot of difference in terms of the efficiency, so it's usually, if you're using a 95 or 100, you can probably get away with a 95. But I tend to like to be better protected, so I tend to like to use the higher ones. Your cartridge respirator, again, this cannot be used in oxygen-deficient environments because you're filtering the air. These have what are called a protection factor of 10. What that means is I can be exposed to 10 times the limit, the occupational exposure limit. So that PEL we mentioned earlier, you could be exposed to 10 times that using this respirator. So it's pretty protective. By the way, this one is also, believe it or not, rated for 10. So it gives you also 10 times. This one gives you the opportunity to put different cartridges in it. So this one only protects from dust and particulate. This can protect from dust and particulate, but it can also protect from organic vapors, acid gases, ammonia, whatever you have, by putting the proper cartridge in. Cartridges are color-coded to select the proper one. Okay. Full face mask. This has a protection factor of 50 now. So I can protect myself up to 50 times the exposure. And this is nice to use if the particular contaminant is water soluble, in that if you get this chemical or vapor into your eyes, it's going to cause irritation in the respiratory tract and your eyes because it reacts with the mucous membrane. So where you have that kind of exposure, using a full face is a better option. So by looking at the colors here, I can tell this is a particulate filter. This is a HEPA filter, high efficiency particulate. And the black part is a organic vapor. It's a solvent type of filter. So you can actually, on some of these, stack them up. Have a combination of colors. Now, one of the things, before you slap one of these babies on your face, is you need to make sure that your body's going to be able to handle that. So when I put a negative pressure respirator on me, what am I doing? I got to suck through that filter media, so it's putting a strain on my respiratory system. When I blow out my carbon dioxide that I'm exhaling, some of that resides in the face piece of the mask. So when I re-inhale, I'm getting not as much oxygen. So because of that, OSHA says if you're going to have people wearing tight-fitting respirators, you need to have them medically cleared to do that. Okay. So you have to do that prior to use and prior to what's called fit testing, which we'll talk about next. There's a questionnaire in the regulation, which is 1910-134, in Appendix C. There's 8 questions, 8 or 9 questions that are mandatory that you fill out. That gets sent directly to the healthcare provider. The employer should not be involved in collecting them. Oh, I see you have this. So they were supposed to be sent privately to the healthcare provider. The healthcare provider reviews them, and many healthcare providers will say, you don't have heart disease, you don't have respiratory problems, you're good to go. You can wear that negative pressure half mask. If I check that I'm a smoker, I got COPD, I'm claustrophobic, et cetera, and so forth, docs might say, hey, we probably should bring you in and do an actual physical and do some pulmonary function testing and see where your lung capacity is at before we give you the permission to wear a respirator. So that has to be in place. And these have to be provided during normal working hours. Okay, so they're convenient for the employee. In addition, after we do the medical clearance, we do what's called a fit test. Now, fit test the old way, back in 1934 through 1972, this was used. And you can see these individuals had a respirator on their face at one point. And what they did is just put this black soot all around their face. And then they would take the respirators off and look for any tracings of that black material that came in from the respirator to see whether the respirator was being effective at keeping out the particulate. Thank goodness we don't have to do that anymore. Right? So today we use one of 2 methods. One is a qualitative fit test. Okay? And so this is the person puts their respirator on. There's 3 or 4 different ways to do this. One is irritant smoke shown here. So they take this irritating smoke and put it all around you. And if you don't choke and gag, it must mean the respirator is working. Right? I don't like to use that one because this smoke is actually toxic. So there's other things we can use, like vitreous and saccharin that can be used, but in that case you have to put a coat on top. So anyhow, you basically do exercises. If any of you wear respirators, you know you got to bend down, touch your toes. You got to turn your head side to side. Right? You got to look up. You got to look down. You can do all these different exercises while we're putting all this stuff to see whether you can taste anything. And then finally, you read the Rainbow Passage, right? Which is a perfect passage for today. St. Patrick's Day. Talks about over the rainbow, there's a pot of gold. And people search for the pot of gold and some never find it. So you're just basically getting the person to talk. See if you can get something into there. Use a Rainbow Passage for that. The other approach is using a quantitative fit test, and this is actually measuring the amount of protection the respirator is providing. To do this, we put a probe into the respirator, and we measure the difference between what's outside in the air and what's inside on the respirator, and compare those two numbers. Okay, so it actually gives us a readout of what the protection factors are, which is kind of nice because it's real specific. This type of testing is required if you're using full face mask respirator, okay? Because the other way is not sensitive enough to protect, to say that a respirator is working if it's providing 50 times protection factor. So this is a much more sensitive method to test. Okay, so those have to be done. They have to be done prior to use, and you repeat these annually. Also, if you change your respirator, you need to be fit tested on that respirator, or if anybody determines there's a need to refit you, you have changes in your body weight, scars on your face, dental changes, cosmetic surgery, all those things can affect the fit. So you would have to have another fit test. And they have to be done on each respirator. So if I decide I'm going to use 3 different models of respirators, I got to be fit tested on each one. And there is a provision for voluntary use. So I tested the air, I found out, hey, it's below the levels that are hazardous. But employees say, yeah, but I really want to wear, some sort of mask or something. It just bothers me. Okay. Suggestion is you give them the dust mask, the little paper one. Okay. All you're going to need to do if you do that is provide them Appendix D. Okay. Appendix D is just a little summary. You can post it in the work area. Appendix D says basically use the respirator the way it says to in the instructions. It says keep it clean, understand that it's putting a burden on your respiratory system, and don't share it with other people because that's gross. That's all Appendix D says. And you're done. If they say, yeah, but I got one of those cartridge ones, I feel a lot better of those, and they bring one in, you have a problem. You need to have a written program, you need to get them medically cleared, and that's it. So it kicks in a couple of things that you have to do now, even though it's a voluntary use. Voluntary use for the paper kind, not so much of a problem. Voluntary use for cartridges, it creates a little burden for the employer. So people have to be trained, and we need to train people that are required to wear respirators annually. So there's specific topics that have to be covered about use of the respirator, including signs and symptoms of exposure to the particular products that you're trying to protect them from. So if you're trying to protect them from xylene vapors, you need to tell them that if they're exposed to xylene vapors too much, they might get a headache, they may have lack of coordination, they may have irritation of the eyes, nose, or throat, and so that they can recognize the signs and symptoms of being exposed to the material if the respirator is not working. Okay, so key points on the respirator, you have to have a written program. If you're requiring people to wear respirators, you have to have a written program.
I have a question on that. You said if we're requiring people to wear them, we need a written program, but under the voluntary one, we're not requiring them, but yet we need a written program.
You need a written program if you're using negative pressure respirators.
Okay.
And it doesn't have to be a full-blown program. It just has to cover maintenance and care of the respirator, medical clearance for that respirator, so it's not the full program, but you need parts of the program.
Okay.
Annual training, annual fit testing, medical clearance, and this is not on any frequency. The frequency is defined by the healthcare provider. And if you're running this program, you want to make sure that your healthcare provider tells you how often. Okay, some healthcare providers say, I'll see you in 2 years. But you could have somebody that's kind of on the edge, and they might say, I'm going to see him back in 3 months. So it's person dependent, right, as to what the repeat frequency is. A lot of companies will use, well, we do it every year, or we do it every 2 years. That may be too much or not enough, depending on the situation. So, and a lot of times, you kind of have to ask the healthcare provider, when do you want to see these people again? When do you want to renew the clearance? Okay, because otherwise, a lot of times they don't tell you, and then it's up to do your exposure assessment. You have to have some kind of assessment of the exposure in the area, and a program administrator has to be assigned to run the program, and they have to be trained. So they have to understand a little bit about respirators and how they work and so forth. There is an annual program evaluation requirement. That I find missing. So if you have a respiratory protection program, once a year you need to go out and talk to the people that are using respirators, evaluate it, discuss it. I would suggest that you document that you've done this annual review. Make it part of your policy. All right, so that's respirators. Getting down to the end, number 3, machine guarding. We knew that was going to be coming. 1,940 violations. Look at the fines. Okay, these are bigger fines. $6 million in fines. Roughly $3,000 per violation. So this is the interaction between the human and the machine. And so there's lots of different motions that have to be guarded or protected. So look for these things in your facility. Rotating pulleys, belts, things like that. We talked about power transmission, so that kind of gets covered. Any in-running nip points. Rotational motions. Stationary and fixed nip points, so we talked about the pestle grinder. Transverse reciprocating motions that are moving back and forth, where somebody could be struck by the moving cable, like in a milling machine. And then the points of operation is really what this violation is getting at. And the points of operation are the points on a piece of equipment where the action happens. That has to be guarded or protected. So you can think about all the different types of machines you have in your facility, where the action happens. How is that guarded? So that's what OSHA is looking for here. So we might have things like punching, shearing, and bending, and so forth. OSHA does have a national emphasis program. Remember, I talked about emphasis programs. They have a national emphasis program on prevention of amputations, which came out in 2006 and has been maintained. So what that means is they're specifically looking for businesses that have the types of equipment that could cause amputations, and they're going out and inspecting those businesses. And there's a whole big process in terms of how do you get on that list. So, labeling things like this, where there's a hazard present, is not considered protected, right? What this does is it shows the OSHA compliance officer where to write the citation, right? So you better, you want to provide warning to people, but that's, you need to really protect them. Another one that you see sometimes are these fans. So people bring in fans because they're hot and they want to get cooled off. Well, if the fan is less than 7 feet above the working floor level, the blades have to be guarded, and they can have openings no greater than a ½ inch. If you take a Walmart fan and you measure the distance from here to here, you're going to measure more than 1½ inch. So those are not legal in the workplace. The other types of fans you see are the ones, and then these usually have these the little zip cord, 2-wire zip cord, which is not designed for an industrial facility. So those types of fans really don't generally have a place in the workplace. I mean, it's not a huge hazard, but OSHA will probably cite it. These concentric fans, OSHA has a letter of interpretation on these. If these are industrial fans, they're designed for industrial applications for cooling. If this part here is greater than a ½ inch, they will allow it if it's strong enough that when you press against it, it can no way get to the blade portion. Okay, so if it's adequately protected, they will accept it. But generally, this type, you can actually push in on those to get to the blade or stick your finger into the blade. Right? Just do that with your tongue when you're a kid. That was just never know how I got into safety. They used to do some really dangerous stuff. So machine guarding. Again, we have fixed guards, we can have movable guards, things like that, but any types of these things have to be protected. There's also methods of protection using other devices. So we can use presence sensing, and here we're talking about a light curtain or something that interrupts the machine motion or action to protect people. This is a electromechanical device. So the way this works is there's a little, so this is an eyeliner, has a little metal piece that comes down here, has an arm that goes up into the box. And so what happens is I can fit the material under there to do the punch or the fastening that I want to do. But if I get my finger under here, it's going to lift this arm and trigger a switch inside the device and will protect it, keep it from actually. The problem with these is usually they're not adjusted properly. People have these bent out to the side or whatever else. We also have machinery that can be protected with two-hand controls or two-hand trips. So two-hand control means I got to have both my hands on the buttons for the machine to do its job, so therefore I can't have my hands in the machine. A two-hand trip is actually one in which you press the buttons and then you can come off of them, and the machine's going to run through its whole cycle. There's no stopping. A two-hand control, as soon as you come off, you stop. The importance on a two-hand trip then is the distance that the trip is from the machine action. So I trigger the machine, and I have to be far enough away that I can't go and reach in and then have my fingers cut off after I hit the trip. There's actually a calculation for doing that. Of course, with any two-hand controls, it's a one-person job. So here we have some adjustments being made, and I'll push this button, you push that button, and then we'll both cut our other hand off. Two people is too bad. And I see that in a lot of maintenance applications as well. You got two maintenance people working together, and one guy's like, okay, hit that control now. Oh, not that one! A lot of problems with that. All right. Number two. Yeah, you know what this is. You only got two left, the two biggies. They're always on the top 10. They're usually in the top 3. Hazard communication. 2,338 violations, $1.4 million in fines. Average fine is $2,338. So you guys all know probably that we changed HAZCOM, right? 2012 was changed. And the idea was to roll all the different world things together. Everybody had their own way to do labeling and chemical identifications and things like that. So we said everybody's going to get together. United Nations came up with an approach in the blue book, or purple book rather, that explains how we're going to approach chemical labeling in the world. And then all the countries are supposed to go, okay, we'll do it that way. And some have and some haven't. The United States has done a little bit, but OSHA is the first really, other than DOT, is the first agency to really get on board. So to make this whole thing work, we'd have to have the Consumer Product Safety Commission, we'd have to have EPA get on board to agree with this approach as well. But so OSHA's leading edge now. So the NOMs are out of Mexico, this is out of Canada, this is out of the EU, obviously, there's standards there. So they're all different, we're trying to actually all get. So that's why this came out. So there's new pictograms, which you all should be familiar with now, that identify different types of hazards in the workplace. You're going to start seeing these on your products coming into your facilities soon, if you haven't already. Employees need to have been trained on this already. There was a deadline that passed for training, so hopefully everybody's up to speed on that. These new labels have a very specific requirement for what's on the label. It's very prescriptive. We do a hazard classification, which is very complex and very involved, as opposed to before we had to do a hazard determination. Determination is kind of saying, it's probably going to do this to you if you even. Hazard classification, we have to actually look at toxicological data, epidemiological data, and make an evaluation of each and every ingredient in the product and come up with a classification by a very prescriptive method. It's very involved. I just had a company call me and said, we have 50 MSDSs we want converted to SDSs, and we need labeling for them. Okay, it's, do you know what's involved? Because there's a lot of time involved. Right. So we went from the MSDS sheet to the SDS, right? We lost the M from Material Safety Data Sheet. So the SDS is a 16-section document And sections 12 through 15, OSHA does not regulate, so they're not mandatory because there's no regulatory agency that has adopted these yet. But this is the format that they're suggesting that they're requiring us to use, with the exception of 12 through 15. So the idea here is you'll be able to pick up any SDS and look at section 4, and that's going to be first aid. It's always going to be the same sections. If you look at MSDS today, the sections are all different, things are different spots, and so forth. So this is a much more prescriptive approach to identifying and indicating information of chemicals. So here's the deadlines. By December 1st, 2013, you have to have trained all your employees on the new labels and SDSs. So hopefully you already have that. When OSHA comes up with a new regulation, oftentimes it gets cited a lot. Because that's what they just passed it. So they're looking for people that have complied with it. So if OSHA walks in and you haven't complied with this, they're going to be kind of feeling like you're not really keeping up to date. Okay. Manufacturers have to use the new labels and SDSs. They have to implement them as of June of this year. And then distributors cannot ship materials out of their facility without the new labels on as of December 1st. And then finally, we have an update because all this new information is going to be coming out. So you're going to need to have your program, your written program, changed to update the changes in your written program and do any additional training that's appropriate for employees by June 1st, 2016. Those are the deadlines. So basically, you have to have a written program. It's amazing how many companies get cited for not having a written HAZCOM program. You have to have a program. In the program, you discuss how you label things, how you train people, how you're going to provide access to the safety data sheets, how you're going to address hazards during non-routine tasks. So you're tearing a boiler apart. Well, how are you going to address the hazards associated with a non-routine activity? Hazards from unlabeled pipes in your facility. My suggestion is label them. Hazard communication standard does not require that, but that would be one way to address it. Multi-employer worksite coordination. If you have contractors coming in and working on your site, how are you coordinating the hazardous chemical components? I was at our concrete plant many years ago, and I walked up, and these guys were setting up to spray. They were spraying the stuff all over the side of the wall, and it was like for noise control. They didn't know it was loud. I said, "What are you guys doing?" I said, and I went over and I looked at the drum they were pumping out of, and it was isocyanate-based material. And I was like, do you have safety data sheets for these? Material safety data sheets? Well, they're back in the office. I said, I'd like to see one. He goes, well, I'm not in the office, so I can't get it. And it's like, well, you have to have it. And isocyanates have an exposure limit of 0.002 parts per million, which is really, really low. So I was like, no, stop. You can't spray this stuff while we got people here. You have to do it outside. Work out. It's cancer, it's respiratory sensitizer, causes all kinds of problems. So, ideally, what we should have had in our workers, we probably did, in the HAZCOM program, there's probably a provision in there where you're supposed to work with the contractors, get their safety data sheets ahead of time, evaluate the chemical hazards, and make sure that people are not exposed. As well as the contractor needs to know what hazards you have on the site. They're up on the roof, and you're pumping out something out of your exhaust pipe, and they're up there working right beside you. Well, what is that I'm breathing in? So you also have to have a chemical list using the product identifier. So somewhere you should have a list of all the materials safety data you should have. This program is available upon request by workers. Accessibility, make sure they're accessible during each work shift to employees when they're in their work areas, and you must be able to access without asking. It's not permissible to have to go to a supervisor and ask, I want to see the safety data sheet on such and such. It has to be readily available to you without permission, without asking to go to a supervisor. Retention requirements. The SDSs are an exposure record. So what that means is you have to retain these for 30 years. You can discard them if you get a new one and the formulation is exactly the same. You can discard the old one. If the formulation changed, you need to keep the old one for 30 years. Instead, you could also create a record identifying what substances were used, where and when they were used. I prefer just to keep the SDS. And what I would suggest you do is just if you're going to stop using it, indicate the dates it started being used and when it ended being used and what departments and how it was used on the sheet. Because the whole idea of this is somebody comes up with a chronic illness, they come back and say, you know, what was the exposures back in the 1970, 80, you want to be able to pull those documents out and say, okay, well, they worked in this department, these are the things they would have been exposed to. Label, 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 secondary container labeling, right? So we got to make sure that anything that's a secondary container, poured from a labeled container into an unlabeled container, has a label on it. That's the old HAZCOM, right? But that gets cited a lot. Employees have containers that are not labeled. So which one was the deadly toxic stuff and which one was apple juice? You don't know. By the way, there are different requirements for labs. So in labs, you actually don't have to label sometimes. We're not to the same extent in the industry. Your labeling, even though we've gone to these pictograms, you can still use this for in the plant label, the NFPA 704 label. Okay, these are the hazards, right? We have the fire, reactivity, the special hazards. I assume you guys are familiar with that from your HAZCOM training elsewhere, or the HMIS system. These labels can still be used for secondary containers, but they cannot be used on the primary container coming in. So the manufacturer or whoever's shipping the material to you needs to use the new pictograms and the new label format in the receiving product.
So if we receive a product that does not have that new pictogram, we should contact the vendor and notify them that it must be changed?
Exactly.
Now, if they say we're going to send you a new label,
Right.
is that acceptable for us to get
Sure.
that new label?
Yeah.
But there might be some time in between. We'll have to
Yeah, so you know, you've done your due diligence by notifying them that they are not compliant with the regulation, they need to be compliant, and you can't receive materials, or the shipper can't ship it without these labels on. You know, they're both in trouble.
Yeah.
You would like to get an updated label as soon as possible so that you're not in compliance, and you know, I would document that so you can show you made your due diligence, but I don't think you would get cited for that. The other thing I find with HAZCOM, process vessels or vats. So if you have like a, you know, like a dip tank or it runs through this material to get, you know, as it's running through the process and there's a tank of it or whatever, make sure they're labeled as to what's in there. That gets mystified. All right, number one, lockout tagout. 2,406 violations, $8 million in fines, $3,325 per violation. So this is a huge issue, and it's the hardest regulation to comply with, therefore it's the most cited. Okay. So, we'll quickly run through HAZCOM. So, lockout tagout. So lockout tagout 1910-147 deals with the servicing or maintenance of machines or equipment where unexpected energization could occur. So that's what it covers, servicing and maintenance. If you're doing servicing and maintenance and there's energy present, and if it releases you would get hurt, that's what we're talking about. One of the problems with this regulation is the scope is a mess in terms of how it's covered and what it covers. Written by too many lawyers, I think. So they go on to say it covers servicing and maintenance. However, normal production operations and servicing and maintenance during normal production are not covered. Okay, so if I'm just doing production and normal servicing and maintenance during production, lockout tagout does not apply to that situation. Unless the employee is required to remove a guard or override a safety device or put any part of their body into a danger zone on that piece of equipment, then lockout tagout does apply. Okay. So if I got to take the guard off to clear the jam, that might be, you might say that's normal production operations or minor servicing activities, but it's probably not. But if it is, I'm taking the guard off, put my hands in it, so lockout tagout applies anyway. Okay. However, there's an exception to the exception, and that says minor tool changes, okay, and adjustments in minor servicing activities during normal production that are routine, repetitive, and integral to the use of that equipment are not covered if you can do the work in some other means that provide an alternative safe measure to protect the operator. becomes very challenging. Working with two companies right now, both of them use dies and presses to make things. And so there's a lot of interface between the dies and the presses and things you have to do. And it's very, very challenging on how, what has to be guarded, how do you guard things, what becomes lockout tagout versus normal machine operations, and then what alternative safe measures can we use that are as effective as lockout tagout. So, there's lots of things to be considered. I did one up in Scranton where I looked at their huge extrusion press. And I was there for 2 days just figuring out the press, and it took me about another 6 days to figure out, for all the things they do on that press, which ones had to be lockout, which ones could be done other ways. And lockout was a big deal for that press because it took them over an hour to lock it out. Because there were so many different points to take that thing down. So we have to consider construction, installation, setup, modifying, lubricating, unjamming, adjusting, tool changes, maintaining, cleaning the equipment. And these are all servicing and maintenance. If they are occurring during normal production operations, then generally you're going to protect these people by guarding them. If it's outside normal production, you're probably looking at lockout. So kind of bottom line is, somebody gets hurt on a machine, you probably violated the machine guarding standard or lockout tagout standard. So I made a little flow chart. This is really was to help me more than anybody understand what we need to do and when we need to do it. So if you start at the top, we have to do a service or maintenance activity. Is it during normal production? No. Okay, well, let's lock it. Is it during normal production? Yes. Okay. Do I have to take a guard off or device or place part of my body into the danger zone? Yep. Well, yeah. Okay. So is it a minor servicing activity, which is routine, repetitive, and integral to the use of the equipment? If it isn't, I have to do lockout tagging. If it is there a safe method that provides equally effective means and protection as lockout tagout? If so, I can use that method. If not, I have to lock it. Continuing down here, if you don't have to remove a guard or safety device, then you can just go ahead and do it because you're not exposed. So those are kind of the bend, but you can see that there's a lot of ways to get up to here and not too many ways to get to here. So when I have companies using this, alternative safe measures to protect employees doing normal production operation activities, is a little concerning because you're down pretty many paths before you get there. I wish I could argue any one of those terms. So the alternative safe measure has to be as effective as lockout, part of normal production operations. It's routine, repetitive, and integral to the use of the equipment. It's minor. So to give you some practical examples, and OSHA actually gives us these in letters of interpretation. Activities requiring machine or equipment shut-off and disassembly, like changing a machine tool, cutting blade, usually take place outside of normal production. So they require lockout tagout. Changing an abrasive wheel takes place outside of normal production. Machine's turned off, grinding operations have stopped, guard is removed, retainer nut is loose and removed. So minor servicing exemption does not apply to this. It's lockout tagout. An injection molding machine has a part that gets stuck. The operator hits the stop control, he opens an interlock guard device, and he takes out the stuck part. This could be a minor servicing activity during normal production operations, where the operator is being protected by the alternative procedure, which is a stop control and interlock guard. So they're saying it may be okay. So that's kind of how to think about it. All right. So, keep in mind, lockout tagout is required in most cases where work's going to be performed. You have your authorized employees, of course, are the ones that are allowed to do lockout tagout, and the affected employees are the ones that are affected by the lockout tagout. Both employees have to be trained. I had one of my clients get into trouble with affected to authorized. What I mean by that is this is a very large company, and they do a lot of woodwork. So they had this huge saw that was cutting. It got jammed. So they did the right thing. They called the maintenance department. maintenance department comes over, they do the lockout, they put the locks and tags on, the whole deal, and they start getting in there trying to unjam it. Well, the operator's sitting there, and he doesn't have anything to do, he's just sitting there hanging out. So, I'll help you. And he grabs a board and he starts helping them to try to unjam it. Well, OSHA happened to be in the facility, and this company had been previously cited for lockout tagout. So the officer looks, there's two people working on the equipment, there's one lock on the box, you have a lock for each person that's protected, it's a violation. Further, that individual wasn't trained as an authorized person to do lockout. So now they got cited for lack of training. So, because they got cited before, it's a repeat violation. Repeat violations go up to $70,000, so this one was $32,000. So be careful that your affected employee or your authorized employees don't make your affected employees authorized. And how that can happen is a maintenance person standing there, hey, can you just hold this for me for a minute? Well, they got their hands in it, they got to be an authorized person. The tag, make sure you're using a tag with your lock, make sure it's identifiable. I see signatures that look like this. Who is that? I don't know. Somebody important if they write like that. Okay. Out-of-service tags are not lockout tags. Lockout tags are only used for protection of people. These are used for protection of machinery. What that means is if you put a lock on a piece of equipment to lock it out of service because people shouldn't use it, it's not ready to be used, and you go home and you leave, and you just leave your lockout that looks like this, danger, do not operate, you're using a lockout lock, that's a violation. Okay. If the lock's on and a tag's on like that, it means you're actively working with the equipment. If you turn that equipment on, you're going to kill me. Okay. This type of tag and lock, if you care to use it, is not protecting an individual, it's protecting that machine from being re-energized. There's a difference. So don't use this for this. I was in one facility, I went over to the tag, the do danger, do not operate, lockout tag, and I looked at it, and I said, who's this guy? He said, oh, he hasn't worked here for about a year. How can you be working on the equipment then? Oh, he's not, it's just locked down. Oh, you need a caution. General lockout policy, you have that in place, but you also have to have energy-specific control procedures for all your equipment. So this is a written procedure on how to lock out your equipment. This gets cited a lot because people don't have these. Individual procedures on how to lock out each piece of equipment in your facility. Okay. There are, I'm going to go a little faster here. So here's an example of a lockout tagout procedure. This one actually doesn't have any electric. So this is an energy control procedure. So how do you lock this out? You also, the person doing the lockout must know the magnitude of the energy prior to the lockout. So that's listed on the procedure here. Where do you lock it out at? How do you do it? How do you verify that you've locked it out? Okay. So these are step-by-step procedures that you have to have for each piece of equipment. There are some exceptions to having these. If you have a single disconnect, I pull the disconnect down, I put my lock and tag on it, and everything's dead. There's no residual energy, no heat in the system, no air pressure, nothing. It's completely down. You don't have to have a written procedure. Single disconnect. All other equipment, there's more than one source, you have a written procedure. The procedures do not have to be posted as they are here, but they do have to be available to employees who are doing lockout tagout. So posting is certainly one way to do that, as an example. Protective gear is needed for lockout tagout, and probably based on our time, I'll go very quickly through this as we're coming to the end here. But if you lock out equipment, you have to presume that it's still energized until you verify that it's been dead. During the verification, people that do work on electricity, they will need to use PPE, insulated electrical gloves, and protection from arc flash while they're doing that verification step. Once they have the verification step done, they can take that protective gear off. So that's at one point. So we go through the process of how to do lockout tagout. And I won't go through this in any detail. You'll have it in the handout that you'll see. So you know, the aqua-colored ones are only required if you're doing electrical lockout. So I can lock out a piece of equipment to change the saw blade. That's one thing, right? Or I can lock out a piece of equipment because I'm going to get into the conductors and rework all the conductors and system inside that. That's different. That's an electrical lockout. For electrical lockout, you need to add these steps that I have in aqua. And when I say you need to, not all of these are OSHA requirements. So here I have NFPA 70E, which is an electrical protection standard. It's a voluntary standard. So this is not really OSHA mandated, but it's a practice that's recommended. So those last few steps here are all electrical based. So you have a copy of that. Your devices have to be standardized for lockout tagout. It doesn't mean they all have to be the same color, but they have to be identifiable as kind of the same type of lock in some format. Use a training, lockout tagout training video. Kind of the same thing with forklifts. Interactive computer programs, OSHA says, are okay, but they're supplemental. They can't be used alone because you're not going to get to the level of detail that they require. The other thing I see people doing is we train everybody on lockout tagout. Train the whole plant. Well, that's okay. Train everybody on lockout tagout as a affected employee, but not as an authorized employee. If you are training everybody and not specifying whether they're authorized or affected, you're creating a huge, huge problem. Be very clear about who's authorized and who's affected. And if you are authorized to lock something out, what is it you're allowed to lock out? Okay, I'm the saw operator, I'm allowed to lock out my saw, that's all I can do. Okay, very simple. Or, I'm the maintenance person, and I can lock out all these different types of equipment. But maybe I can't lock out the saw. Be specific about what I'm allowed to do. Okay? The reason for that is you have to do auditing. Every person has to be audited doing a lockout tagout on every piece of equipment they're authorized to lock out. Once a year. You have to document that audit. So this is very time intensive. The audit's done by another authorized employee who is not involved in the lockout tagout. So I have my saw operator, I'm authorized to lock out the saw as well. I would have a form, I stand there, I watch the saw operator do his lockout, I document that he's doing all the things according to our written procedure. All good, I sign and date it, put it in the file. We're good for a year. So OSHA will come in, they will ask where are your energy control procedures, we'd like to see them, and where are your audits of the energy control procedures and of the individuals that are authorized to do lockout tagout. You see why this is number one? There are ways to reduce the burden. You can group procedures together. I have a saw here, I have a drill press here, I have another saw over here. They all kind of work the same way. You all pull the disconnect and then you disconnect the control voltages here and you put locks on. They all do this, they all get controlled the same way. I can group those procedures because they're all kind of the same, even though the equipment's different. So I can group them. And then now all I have to do is do an inspection out of each group. So I don't have to inspect every procedure now, I just have to do a random sampling out of each group to kind of get a sense of that. And I don't have to inspect every single operator that might do these procedures. I could randomly select some of the operators, and then what I would do is talk to the other operators. Say, when you lock this out, how do you do that? Is this how you do it? Yeah, okay. So I talk to so-and-so. So you document that. In addition then, while annual training is not required, you can do annual training to help meet your requirements on these inspection aspects. So what we would do is after we do these audits, we make them available and we review them in an annual training. Okay, of the audits of the energy control procedures. And OSHA said we'll consider that to be part of the way you're meeting your requirements of not actually inspecting every single person and every single piece of equipment that they're authorized to lock out. So you see the problem with authorizing everybody in the plant on everything? It's an insurmountable approach. It's a
compliance. Don't forget your vehicles. If you have vehicles in your facility, they have to have a lockout tagout procedure for the vehicle. Industrial truck, whatever it might be. People might need to work on that, do service on it. If they do, you have to have a procedure. All right, very last thing, just the fine amounts. So that was by order of most citations issued, number of citations handed out. How about in dollars? Total dollars, lockout, tagout. Yeah, still number one. Machine guarding. Number two, process safety management, which didn't show up at all. These are big fine dollars. Process safety management, most of you probably don't have to do. If you have over 10,000 pounds of flammable liquids on your property that you use for your processes, not for heating, not for fuel, you're using for your process, then you're under PSM. If you have certain chemicals that are particularly hazardous, over certain quantities, in some cases over 100 pounds in your facility, then you can be regulated by PSM. PSM basically is a crazy regulation. I'm working with a company right now that has to comply with this and got cited $40,000 because they didn't comply with it. So this is number one in expense for fines. And keep in mind, while it's only $4,183 per violation, many companies get 10 of these or 15 of these for the PSM violations. So there are different citations within that section. So if you are covered by that, you got to really make sure you got that down. Most of you are probably not. On dollars, number 4 was power industrial trucks. And then I'll just kind of zip through the last ones here. Electrical. General duty clause, which was number 2 for the highest average fine, number 7 for the total aggregate dollars. General duty clause, if you don't know what that is, 5A1 general duty clause says you have to provide a safe workplace. That's all it says. So if you don't provide a safe workplace, OSHA cites this. So that means anything, they don't even have to have a rule. If it's not safe, they can cite it. Now they have to prove. There's a level of proof that have to do. All right? So that's kind of how the rest as for dollars, HAZCOM was actually the number 10. Number 2 and most frequent, but number 10 for dollars. And you guys all know, you got to tell them, just change. Death in 8 hours to OSHA, that's not changed. And if you have a hospitalization, you have to call OSHA within 24 hours. That's changed. Hospitalization, admission to the hospital for work-related injury, 24-hour notice to the agency.